Okay, so welcome to this tutorial session on Python. I'm Senthil Kumaran. I've taken a similar kind of tutorial last year, and it was well received. So I took a tutorial on Python standard library modules, where I concentrated on different libraries which are available in Python. But this year, I focused to concentrate in a bit different way. Basically, introduce you to the problems which many software engineers and programmers come across, and how do we code them efficiently using Python. Okay, I work for this company called Akamai in Bangalore. So Akamai is a content delivery network, which you might be aware of. So it's based out of Boston, Massachusetts. And at work, I use Python too. So Akamai, if you know about the content delivery network, it's like if you're watching some videos over Hulu, it's getting served by Akamai. And if you're watching video over BBC, so it is served by Akamai. And it's basically like to enable faster websites. And it's not just caching, but it's a lot of things which is going on within the Akamai network. And who are the people who are in the web world will know about Akamai, where they subscribe to this business and to make the video on the web faster and make the high definition on the web faster too. Apart from that, so my foray into Python started some 4 or 5 years ago, and I'm one of the co-developers of Python, where I contribute to the Python standard library, and I focus on the URL library related bugs. So any bugs which comes in Python, URL lib and other areas, I tend to assign it myself and work on it to fix it. So it's been going good with lot of modifications coming up in URL parse, URL lib, and all the related modules in Python 3. So yep, that's it. In this tutorial, I hope that you all have an introductory knowledge of Python. So you either must have attended yesterday's sessions of Python 101, and you come here for the second session, or you might already be using Python or some other language, of course, Java or Perl or C++, etc. So I assume a certain level of programming experience in this tutorial. So even if you don't have a programming experience, that's fine, because all the snippets here are very short, and you should be able to follow it easily. Okay. If you have any questions in between the class, just raise the hand and ask me. We'll spend some time on it so that it gets clear, and we'll proceed. And I have a request to you that, as I showed, in this website, youthcode.server.org, I have the PDF and the source code available. I want you to download this. Okay. The reason I want you to download is I have the source code of Python 2 and Python 3 available both. And when you are attending this tutorial session, if you try out those source code snippet, you will understand it best. Okay, so a prerequisite of this class was Python 2.6 and Python 3.1 installed together. And you might need a twisted library installed, but twisted examples I'm not going to cover in deep. So there are a couple of examples here which I can show you. But you will need, if you are having a laptop, you will better install Python to have a good experience with this tutorial. So this was the zip file which I downloaded. Here is the PDF version of it, our class. Okay, if you would like to browse using the PDF readers, this is fine. Or you can browse using the browse online too, which is fine as well, because the source code is decorated, if you see. So you will find that the source code is decorated, and you will have a better understanding. Shouldn't be a problem. Even the same with the LaTeX PDF. So you will find that source code is indented and properly, it has good formatting. So it should be fine reading using the PDF too. And here is the Python 2.6 source code. So I've made sure that if you see that there's a color difference in these files, the ones in greens are actually executable. So what I mean by that is like when I open any of these files, so I have this shebang line on top. Okay, that's actually called the shebang in Unix-based systems, where the shell interprets that file. So on top, this file is actually executable on Python 2.6. So when I execute this file, like as you execute any other, so this is actually interpreted in Python 2.6. Okay, when I go to the Python 3.1 folder and open the same file, it was how to 6, and you see that it's linked against user bin env Python 3.1. So what this shell construct means is it looks for the environment where the path of Python 3.1 is, and then executes the rest of the source code using Python 3.1. So this snippet will be executed against the Python 3.1 interpreter. So there is obvious differences between Python 2.6 source code and Python 3.1 source code. So you should basically interchange them. Yeah. So for example, this was executed using Python 3.1. If you downloaded this zip file, you can play with the snippets which are there. Everything is completely executable, nothing should break. And once you play with those snippets and make some small modifications and try it out, you will understand things better. And that's how many people learn too. OK, so let's get started. OK, so the first task which I'm going to focus on is recollecting certain common programming paradigms. OK, regular expressions. I'm taking this tutorial from a programmer's standpoint. OK, so my basic idea in designing this tutorial was how, as a programmer, what are the kind of modules and the tasks which I've come across, and where I and my fellow developers needed most help. We've focused on that and then collected some of the materials and then put them all together. So let me give you an overview. We will recollect some of the programming paradigms, okay? And then there are some interesting modules which ease our tasks when using Python, okay? Then I'll focus on strings, files, datetime, processing XML. At this point, we will be having a break, so after processing XML. And then after the break, we'll be focusing on databases, process handling, network programming, web programming, unit tests, and some programming tasks. And of course, a last session on how to convert your Python 2 to Python 3. Okay, so there is a 2 to 3 module available. I have a source code which is Python 2. So we will run it on 2 to 3 module and see what changes we are going to make on to make it compatible with Python 3. Okay, so that's the thing. We got to keep up on time. So I'll do one. OK, that's fine. This is my old time, so I'll anyway reference it in a relative manner. Don't worry. OK, so let's recollect the regular expressions library available in Python. So Python comes with a batteries included philosophy where a lot of commonly needed modules are provided to you. So regular expression is one such library, one such module. Okay, it's C. It's written in C, and it's so when you want to import regular expression module, you import RE, and then you compile a regular expression using the regular expressions compile method. So what do you mean by a compile method is regular expression supports certain kinds of syntax. Okay, if you're aware of or used regular expressions, the start of a line is denoted by cap, the end of a line is denoted by $. Dot stands for any character, dot star stands for any repetitions of a character, plus stands for a single character, a question mark stands for a if or else character. Okay, so the regular expressions stem from the computer science theory of finite automata, where if you want to match a number of characters together, you start with one character and then proceed with a number, proceed later using some it's a small grammar in the language in itself. Okay, it's not full-fledged. So in computer science theory, you have this various hierarchy of languages, and at the lowest level, where you can recognize patterns, is where regular expression stands for. And this snippet, re.compile AB star, should basically compile a regular expression object of words which are start with A and 0 or more occurrences of B. Okay? So when you compile a regular expression object, you get a regex pattern object, which is here. Okay? And it also accepts the optional flags. So in order to search for this pattern, I will use these methods, which are match, search, find all, and find iter. So any regular expression object which I've got using a compile method, I can operate on them using match, which will match if the regular expression matches at the beginning of the string. Search will scan through the string looking for any locations where this regular expression matches. Okay, and find all should basically find all the substrings where the regular expression matches and return them as a list. And find iter should basically return the iterator of all the matches of this particular substring. Okay, so the iterator will be available where you can iterate over the matches. Okay, there's something interesting which I want. So this example was. There's something interesting which I want to share here, that the regular expression have a substitute method too, where any match you find on a pattern of text, you can substitute it with some other text. And the Python's regex modules provides a subcall which can take the first argument as a function. Okay, so on any match object, you can invoke a callback function on that. So you find that this regular expression, it's a special flag here, which I have meant by /d matches for any digit. Okay, so /d will match for any digit, and plus will go for one or more times. So when I have compiled a regular expression object of type /d plus, and in this object, I can basically substitute all the occurrences of numbers in this code with the function callback, which is hex REPL. Okay, so what's actually happening here is this is our string where we act the regular expression on. It will match all the digits in this string and then call a function called hex REPL. So the hex REPL will take this match object, and then this match object's group will be given the exact match which did it, and the value is converted to a hexadecimal value and substituted. So when we run this expression, we find that the values of these are substituted with the hexadecimal. Okay, so the regular expression substitute object has this interesting feature to work on pass a function rather than just text. Okay, so this is one common programming paradigm working with regular expressions we come across when doing text. And another common programming paradigm, basically paradigm, or what do you say, you will need to understand is the exception handling. So Python provides exception handling in the form of an except statement with an exception. There are different kinds of exceptions depending on the kind of error which is raised. Okay, in Python 2.6, this kind of a construct meant that any expression is assigned to the variable ERR. Okay, so when any expression, when an error is raised, that exception is caught and it's assigned to the ERR variable, and you can print that out and use it as however you want. Okay, but commonly programmers misunderstood when they gave not just ERR but some other exception name. They thought that it is catching that many it was catching the kind of an exceptions. In Python 3.0 or Python 3K, there was a change in the exception handling. So look at, I think I have to change the color. That's fine, right? Yeah. So this was a common misconception error, which was like prevalent in the beginners, that type error, comma value error. People kind of expected that both kind of errors will be handled, which was wrong. Okay, what was actually happening in Python 2.6 is a type error is caught and it's assigned to a variable by name value error. Okay, so in Python 3.0, this was changed. Actually, in Python 2.6, if you have to catch both type error and value error, you had to basically enclose them within the brackets. Okay, so this was the way, but people used to do it this way, and then this led to an error. So Python 3.0 made an explicit assignment. Instead of comma, it uses an as the keyword. So try accept a type error as exec. So instead of the comma here, which we see, okay, in Python 3.0, you have to use the as keyword. Okay, so
is there a way, like right now in 2.6, you can do the from future to do things like print? Is there anything similar for the exceptions? You can start programming them now.
Yep. So from future, you can import the exceptions to handle them as. And in Python 2.6 and Python 2.7, the features in Python 3.0 are getting backported. So you can use them in Python 2.7.
Do you have a name for that one?
I'm not able to recollect. I know it in Python 3.1 for sure. Okay. So this is an exception handling thing. And then there's iterator. Iterators is something which is prevalent in the Python 2.3.1, basically. The reason I'm focusing on iterators and list comprehensions and others are, like when we start seeing the snippets, I'll just mention them as iterators, and you'll have to understand them. So iterators, you will know that they are kind of a list, which you loop over them, but it's not actually a list. It's a context. It's based on the context. So basically, it doesn't load the entire object into memory, and only when you call each element, the element is obtained from the iterator. So, the good thing about iterators is like they don't load the entire stuff in the memory. So that was seen as a very good feature, and Python 3.1, that's most prevalent. Anywhere it was used to return a list, now it returns an iterator. Okay. So those are some of the changes which are there in Python 3.1. Is the list comprehension. Basically, when you want to operate something on a list to obtain a sublist or change or mutate the list, instead of operating on the loops, you could do it in the list comprehension, which follows this pattern that, look at this list, which is a line with a \n, line 2 with a \n, and the rest. So this will return a generator expression because I have enclosed it with the curved brackets. Okay, the square brackets will return a list. The syntax for the generator expression and the list comprehensions are almost similar, except for the kind of the brackets which you use. Okay. So this is a simple example of a list comprehension. It takes an element in the front, and then it follows a for, in, and if. So a for loop over any number of if statements. Okay. So you have for all lines in the line list, strip the line content. For line in the line list, this will return a list. Okay. So here is the if statement inside this list comprehension, where you will check if that element is not an empty one. Only then put it into the list. Okay. In order to have a generator expression or a list comprehension using tuples, it was basically determined that you have to enclose them within the, you have to surround it by the parenthesis. Okay. So this is the correct example for list comprehension using tuples. The above one is a wrong one because it was not surrounded by the parenthesis. Okay. Generators are a special class of function which help us to write the iterators. Okay. So what is a generator is nothing but any function which uses yield instead of a return. So when you use an yield in a function name, it will return a value, will remember the state of that, and then next time when you call it, you can invoke from the next point on. So That's another thing which you will have to remember. Okay, regular expressions, then so we just saw regular expressions. We saw a brief of exception handling, this iterators, list comprehension, generators. That's it. We will go with some of the interesting modules, but before that, I would like to go forward to the string and then come back to the interesting modules. We'll see some practical examples and then we'll keep going. Okay. So I want to head towards the strings. Okay. So I want to ask this question: is how many people are familiar with Python 3.1? At least heard of it, or yeah, you kind of like used it, or anyone's started using Python 3.1 yet? Okay, I see. So this was the major change in Python 3.1, which everyone is aware of. The strings which were ASCII in Python 2.6 is now UTF-8, and the string which was basically a string in Python 2.6 is now an Unicode in Python 3.0. So I will give some details on the Unicode class and the string, and then let's look at the examples in here. Okay. So look at this snippet, which is a Python 3.1 snippet. Okay, you got to see that this is a filter class. It filters out certain strings from the content. So let's start with this snippet here. You see that it makes a filter of A, E, I, O, U, and Y, which is like vowels with an extra character, and some funny characters, which are like mathematical symbols. Okay, so these kinds of characters are called Unicode. Okay, you don't have the corresponding ASCII value for it, but you have a representation in the Unicode. And when you have typed in with that, what this program aims to do is filter the characters, these characters, from the next string, which is this. The funny character, maths character, and then something about strings, and then there is the sigma, which is again the maths character. So when I execute this program, okay, you will see that every other character in this string, the bottom string, should be deleted or removed, except for the characters in the filter. Okay. Oh, yeah, here it is. So it didn't print in the straightforward way of A, E, I, O, U. You might have assumed that it's just printing that. But it basically went through the entire string, looked for the characters which it wanted to filter, and then did a filter. Okay. Let's see how this program is working. Okay. So when you call the make filter with this string object, okay, make filter is nothing but a keeper class reference. Okay, this keeper is a class name, which is like is a new style class, and this basically takes an argument which is keep. This keep will be assigned to the string A, E, I, O, U with these two funny characters, and then what it actually does is it does a mapping. Mapping basically passes them through the ordinal function, which returns the integer corresponding to that character, and then passes them to the set. The set will create a unique characters of the set. Set is a mathematical operation of creating a set. Okay. Now, the get item and the call function. The call function will be called when you call the function. Okay. Get item will basically get the item from that string. Okay. So these are calls implicitly in that function. Okay. So when you do a call and a translate, so it looks like this. If the n is not in the self.keep, return none. which is like if the string, if when we pass this string something about strings next, it will implicitly call the getItem function. Okay, it will look at that string and see that if the character in the keep, which is like the number of characters which we set, okay, if that is not in the string, return none. Otherwise, return a character reference to it. Okay, this was a Python 3.1 code, and you will see some interesting thing that I didn't make any special cases to put the Unicode characters in there. Okay, in Python 2.6, this is not going to be the case. Okay, let's see the difference between the Python. So look at this difference. I mean, is the diff visible? I want you to see so this is Python 3.1 code on my left-hand side, and this is Python 2.6 code. Okay, you can see it at the top line that the two files are different. Okay, the important thing to notice is here. Look at my cursor, that there is a U. Okay, Python 2.6 has two kinds of strings, which is like a plain string and a Unicode string. And the Unicode string had to be prefixed with a U in the front. So if you don't have U in the front, and also if you see this line, the second line, which is not very visible here, okay, but here it's visible, that you have to declare the encoding. Otherwise, Python 2.6 will not understand the kind of an encoding it is. Okay, when it comes to this Unicode and the encodings, if you see this, right, this is the ASCII code chart. And if you see the ASCII code chart, the numbers 0 to 127. Okay, 0 to 127. It's on far left. 177. 127 is the decimal value. So it's 7 bits. Okay, and the extra bit was allowed to basically make a byte, and then extra bit was like codified into OEM, and people used Latin 1 character set. So what it meant was ASCII and the Latin 1, whereas 8-bit encoding, 7-bit ASCII is the 7-bit encoding, and the Latin 1 is the 8-bit encoding, and 8 bits are a byte in the computer terminology. So any character which is an English character with the European characters can be supported in the ASCII encoding. Okay, but if you want to use your mathematical symbol or any other language text, you cannot rely on the ASCII encoding because there is no code point available. If you see this, right, so here is something. The L corresponds to 108, M corresponds to 109, N corresponds to 1110. The 6 corresponds to 54. Okay, we have the English characters and the Latin characters available here, but we cannot have, Latin characters are not, but the English characters are available in the ASCII encoding. So we don't have the maths character, the Chinese or the Hindi or whatever characters which all the world uses. Okay, so for that, a system was developed called Unicode, which codifies all the characters in the world in the form of a code point. Okay, this code point is available in the Unicode's website, and I recollect certain code point. So for example, if 2202, okay, let me see what this code point 2202 means. Okay, in GNOME terminal, I can put this like this. Okay, 2202 corresponds to that symbol, just like 61 corresponded to some character in the ASCII code chart. Okay, 2210. Let me put 2210. Oh, that corresponds to this symbol. Okay, but what's actually happening here is my terminal has an encoding called UTF-8. And when I put that code point, it is able to interpret that code point's value and then display the character. Okay, similar for the Python program to understand, it needed to have the encoding, which is UTF-8 encoding, so that it can interpret the funny characters here, like the inverted triangle and all those things. So the important in Python 2.6 was a separate string type by name Unicode, which is different from a normal string because it had to have an encoding associated with it. Okay, and instead of returning a char used to return only the ASCII characters. There used to be a function by name unichar, which used to return the Unicode character. So you find that there's a unichar character, and then there was a Unicode method which translated the bytes into a particular Unicode. Okay, so you find those things here. And if you don't have this declaration, right, I'll put it somewhere. You'll see that this Python program will just bomb. Oops. Oh no, I'm in the wrong place. Yeah, so here it says it's a syntax error, non-ASCII character in the file. Okay, why is it saying this? There's a syntax error in the non-ASCII character in the file? Because, okay, it further says that, but no encoding declared, which means that it is not understanding the kind of encoding which is used in the Python script. Okay, which is fixed by basically putting this encoding declaration on the second line. It basically interprets those the rest of the Python script based on the encoding which you specify. This is an Emacs style of encoding declaration. So now you see it working. Yeah. So if you see it again, you see that the differences between the Python 2.6 and the Python 3.1 is a character instead of a unicharacter. Okay, you don't have to explicitly specify the encoding because in Python 3.0 every string is a Unicode string, and by default the encoding is UTF-8. Okay, this particular example demonstrates it well. And yeah, this is an example of how to filter out the characters from a string. You define a class where you define a get item and then iterate through the characters which you want and look for this, like if this character is not in here, return none, otherwise return the character. Okay, that's that. Okay, so that's filtering from the set of strings. Okay, so there's a translate method and the make trans function. So look at this example, which is like, so there's a translator function. Let's start with this. Okay, there's a translator function which has a keep argument or a delete arguments, and in the keep arguments, when we specify a list of what needs to be kept, or basically a string of what needs to be kept, it will keep only those kind of strings or characters in the list, and then it will ignore those. When we see in the delete arguments what needs to be deleted, it will delete those characters from the string and then keep the rest. Okay, when I execute this program, I will see that the first one should keep the digits and then delete the rest of the portion, which means that it should delete the Senthil space hyphen, and then we'll just need to keep the digits 007. When I need to delete the string dot digits, it should delete the string digits and then keep the rest of the string. Okay, so how it's doing this? So that if you look at the translate function, it takes a number of parameters. Okay, it takes a from and a to and a delete and a keep. Okay, delete and keep are basically our main arguments which we are using. From and to is a table. It's a table. It's a table lookup. So what it is doing basically is string objects have a make trans function. If you in the tutorial notes and in this section, I've mentioned that the string objects has a make trans function which return a translation table suitable for passing it to the translate that will map each character in the from to the character in the same position to. Okay, look at it this way. If you have a table where 1 to 10 is on the left-hand side, 10 to 1 on the right-hand side, what it means is that the first element in the left-hand side, which is 1, is replaced by the first element on the right-hand side, which is 10. Okay, so this make trans is creating a similar table like that, but it has a limitation that it works only on 128 bits, which is basically a 8-bit character. It is limited to the ASCII version of it. Okay, so this translation table, this make trans function creates a translation table which is sent to the strings translate method, which takes the table as the second argument and then gives the resultant string, which will replace all the characters in the string in the left-hand side value with a right-hand side value. Okay, so what's actually happening here is all characters are same. Okay, I'm not going to replace anything. I'm creating a table, translation table, consisting of same characters which are on the left-hand side with the right-hand side, nothing else. And what I'm doing is for the all characters, I'm translating the characters and then I'm keeping that. Okay, that's something interesting going on here. Okay, the translate is basically a closure. What I mean by a closure is this translator, which is a function, defines an inner function by name translate, okay, which is returned as a function. So when I return the translate, this yes, this will take a the yes is the string which is getting passed here. Senthil-007 is this yes, okay, and this will look at the translate.trans and delete. Okay, which will again be called with these characters. Make trans will create all the from and the to characters, and then it will delete the functions in the characters. So what's actually happening here is it will keep all the characters in this all chars, and then will call this one to basically delete the characters which are not required. Okay, it works on a closure basis. We'll revisit it later when we come across the closure thing. Okay, that's to do with how to basically delete filtering characters and then how to delete certain characters and keep the characters using the functions. And what is the best method? So now comes to some simpler examples, leaving the closure aside. Let's look at some of the simpler examples. Okay, checking if a string contains a set of characters. You might know that Python, a string is a sequence, correct? Just like a list is a sequence. So an in keyword actually tests for a membership in a sequence. So if anyone gives you a sequence, and then if anyone gives you a set of characters to test and asks you that does this string contain these set of characters, what you usually do is you loop over the characters in the sequence, and then if you see a character in the sequence, you return true, otherwise you return false, right? So this is a simple function. Okay, how to 3 string any character. Okay, so if you see the string dot digits, this returns a string of 0 to 9. Okay, so this is what I'm passing on as a set. When I call contain any, what is actually happening here is this sequence is 916, and then a set is digits, which is 0 to 9. Okay, so if this, and what actually goes for is it iterates over the sequence and checks if any of the characters is in the sequence. If it is yes, it returns a true, otherwise it returns a none. Okay, it's good to check it this way because as soon as you find something, you will return true. That's all we want. So here, because 916 was a character in the string, we have it here. If the first one will be false because my string ABC did not contain any digits. Okay, so what actually happened is like it iterates over the smaller sequence, which is the sequence which I gave, and then checks for each character in the sequence into the set, which is the string dot digits. If it is present, then it returns true. Otherwise, it returns false. Okay, there is another way to do that. And this is the most common and the easy way to do it. There's another way, which is using the iter_tools module. The iter_tools, which returns an iterator for the. So what it does is it does a filter function. Okay, it looks for the sets contain object, contain method. Basically, it says that how it will work basically is it takes the sequence of the characters and then passes as a filter to the iter_tools module. The ifilter will return an iterator. Okay, and the filter function ifilter will filter out the characters in the string to the function which is aset.contains. Okay, so the aset.contains, it's a container test. If it contains, it will return true. If it doesn't contain, it will return false. And the module on top should be returning an iterator. So as soon as it finds a true, it will return a true. Otherwise, it should return a false. Okay, so the iter_tools way is one way to do it, but it's like what you can say, it's a hard kill for such a simple task. And the most easy way to do is the first method, which I showed. Okay, so that was the thing. And how about reindenting a string? Okay, so look at this one in this example, which is how to for. Here I have a sentence which is like not well indented, which has a number of spaces in the front. The back is after the last character there are spaces, and then here is the ununiform number of spaces in the string. Okay, so what I can do is like write a reindent function, okay, which can take a number of spaces which you want to format it on the left, and then write a leading space. As you know that the star operator can take any string and then return a number of strings like the number of strings of the count. So what this reindent is doing is it takes a num space and then multiplies the num space with the space character so that we get the leading spaces which we want. And then it does a list comprehension of the lines of the string. So it iterates through all the lines in the string, and then it adds a leading space at the front, and it actually strips out any leading space existing in the string. Okay, in order to understand this snippet, what you have to do is, you have to focus on the string.splitlines method. Okay, the sentence here is like not well indented, and then splitlines will return a list of lines of the sentence. Okay, and we then go for the list comprehension for line in the split lines, which is like, because it is a list, it will give one line at a time, and then we are doing a line dot strip, which is removing the leading and the following spaces in the line. Okay, and then we are prepending it with the leading space. You see the number of things which are going on in this small snippet. Okay, quite a lot of things are going on here. So you got to see that within these two lines, okay, there's a split lines which is splitting the line string into a list of lines, and then it executes like this. First is for line and split lines is called, and then line.strip is called, which will remove the leading and the preceding white spaces, and then it is prepended, or it's basically like which is like you include the leading space in the front of it, and the leading space is again configurable by our reindent function. Okay, how do we determine the leading space? We determined it by the num spaces attribute. Okay, the num spaces actually by default takes 1, so you will prepend it by one leading space. Okay, if you want to prepend it by more leading space, you can specify it there. So what it has happened here is like the lines is a list which is generated by a uniform strings. Okay, at last there is another construct which is a string.join, which takes a iterable as an argument. Okay, what this method does is it takes the string. Okay, it takes each and every element of the sequence in the lines, and then appends the \n and then prints it. Okay, this is one of the Python idioms which you got to be familiar when you start using Python more. That so you see that this was the sentence which was not formatted. Okay, and now this is the sentence which is formatted. You see how it acted upon? It took the sentence, did a split lines on the sentence, which returned a list of all sentences, did a strip of each line, which removed the leading and the following backspace, and then prepended with the leading spaces, which was configurable again, and then it printed it out. Oh, before printing it out, it did a string.join, the \n of join of the list. Okay. Yep. So if we pass some argument, say for example 3, this will indent it further. See the example from the top to here, because it was reconfigurable. Okay. I hope you get this example. We'll move to the next. Yeah, this is something interesting snippet. Okay, making multiple replacements in a string in a single pass. So this is an interesting problem in itself. Okay, let us look at it again from this point. See, when someone is leading you through the tutorial or this thing, we'll just jump to what it's supposed to do, and then from there we'll understand what it is doing. Okay, look at this. The text is Larry Wall is the creator of Perl. Okay, within a single pass, we have to replace Larry Wall with Guido van Rossum, creator with benevolent dictator for life, and Perl with Python. Okay, so how will you do that? You can basically find and replace on a string methods. Okay, strings have a replace method. If you do a string.replace, string.find, basically you can replace any word with another word. Okay, but there's something more interesting than that. Okay, here is one way to do that, which is a multiple replace method. Okay, and this construct, Larry Wall with Guido and Perl with Python, is a dictionary. It's a Python dictionary, which is a key value pair, which you will understand. The left-hand side is the key, and the one on the right-hand side is the value. Okay. Fine. Okay, so what it is doing basically is it's taking, let's look at multiple replace function first. This multiple replace function is taking a text and a dictionary. The text for us is nothing but the Larry Wall is the creator of Perl. Okay, and the dictionary is what we want, the set of key value pairs where we want certain keys to be replaced by certain values. Okay, look at this. It is creating a regular expression object. If you recollect the beginning of the tutorial, I said that we can compile a regular expression object. Okay, so this is compiling a regular expression object, which is an OR object. So in regular expression, if you have this character, that pipe character, what it means is it's an OR. Okay, it looks for A or B or C or D. Okay, so in this case, what it is doing is it is creating a dict, which is basically a keys of the regular. It's escaping the map function. Map is again a Python construct where it takes a function and a sequence and it passes all the elements of a sequence to a function and returns a function. Okay, so this will create a regular expression object of Laravel or creator or Perl of all the keys with an escaping. Okay, because regular expression has a special construct for space, for digits, and some other thing, you have to escape them. That is why the re.escape function is called. Okay, once you escaped, it creates a regular expression object, and then what it is doing is it's doing a substitute method, and in substitute it is calling a function. Okay, so if you recollect the first page of our tutorial, it shows that I said that the regular expression object can be a substitute method can call a function. Okay, here what I'm doing is basically on every match of that object, okay, this function is invoked. One translate is invoked on the match object, which will do nothing but take the match object, which is Laravel, and then pass it on to a dictionary, which is adict, which will return Guido van Rossum, and then return that, which will substitute that. So what's happening is this entire sentence is looped only once. Okay, this entire sentence is just gone from left to right, single pass, and it looks for those objects like Laravel. Once it finds, okay, Laravel or Perl or creator, and wherever it finds the object, it calls a re.substitute. And what will it substitute with? It will substitute with the corresponding value in the dictionary. Okay, so at the end you find that the substitute method calls and replaces the string in a single pass. Okay, there is an alternate way to do it, which is the closure-based approach, which is more different, and it's kind of like it needs some kind of it's a different way of doing it. Okay, so
what's re-escape again?
Oh, re-escape escapes. So for example, Larry space wall, right? The space has to be escaped. So re-escapes does that. Okay. There's a closure-based approach where a dict is created upfront, okay, and it's like this. Okay, when will you use this closure-based approach? Is like you want this function. Look at how I'm using the closure-based approach. Okay, here I pass the dictionary and in this example, the first example, I passed both the text and the dictionary together. Okay, and if you see this, every time we call multiple replace, using the dictionary, it will compute the regular expression again and again, and then it will look at the text. Okay, but look at the second function, which is translate. Okay, translate, I am passing only the text, because I created a translate function, which was a closure from the dict already. What it means is I pass on a dict upfront. Okay, I pass on a huge dictionary of files. Basically, like I pass a dictionary that wherever Laravel comes, replace it with Guido van Rossum. Wherever Perl comes, replace it with Python. Wherever creator comes, replace it with benevolent dictator for life as a dictionary. Okay, and then create a closure function of it. Closure function, it might have pre-computed the replacements already, and then I pass on any text message to it. Okay, I can pass on a whole O'Reilly book text to it. It should replace everything and then give the output. Okay. And the good part of that is it didn't compute the regular expression replacement in every turn. Okay, it had only once it had to compute. How it does basically is it is similar that the make translate, it returns an xlat, which is a function. Okay, a closure is something where a function returns in a function. Okay, so in the make xlat, I basically form a dictionary again and then do a similar thing, creating a regular expression object. And what I do basically is I define a text, I define a function which will do a substitution and return a function. Okay, this function was done here. If you see, this is in the form of a function. I return this function here. But in the previous example, I did it like I did the operation outside of a function. I didn't basically do it inside of a function and return a function. Okay, when I do a closure, which is like which I do an operation within a function and then return a function, what I get handy is like a pre-computed object where I can pass on any text to it, and it will keep returning. It will keep working on without computing the pre-computed regular expression object. Okay, so this will do the same thing again. If you see, only understanding which is required here is, even here the 1xlat returns the same thing, correct? So both these functions do the same thing, but here, instead of returning a substituted text, I'm returning a function. But what this function in turn is doing is, this function is returning the text. Okay, when I'm returning a function, what I can do is I can assign the return value to a function here, translate, and I can call that function's text. Okay, this is where the interesting thing comes in the closure-based approach. There, we just call the function with the text and the dictionary, and it returned the output. Here, we call the function with a dictionary of what we want to search and substitute, and it in turn returned a function because xlat is a function here, and this function is this function. Because we are returning a function here, this translate is a function for us, and this translate function takes a text argument, correct? So we will pass on a text argument, which will substitute the which is again a regular expression substitute method of calling this callback function on the text object. Okay, it's kind of intertwined, but if you spend a little bit time on it, you kind of appreciate the kind of interesting things which are going on here. Yeah.
Is there any benefit in using any one approach, or it just multiple?
Oh, this one is simpler. The first one is simpler. This.
And then from execution point of view, is the closure approach faster, or just multiple ways of doing the same thing?
Okay, closure approach is used when you know that you want to pre-compute a set of values upfront, and then go ahead with any different kinds of text. Okay, for example, in this closure approach, this text can be anything. I can have text 1, text 2, text 3, and loop them all over different texts. And what I find is the regular expression is computed only once. Okay, this portion of the function is computed only once. Whereas in the other approach, I will find that the regular expression compilation, then the function is computed again and again. Under certain conditions, closure approach is faster. Yeah. And it depends on how you want to break the problem. And yep, it is a bit difficult to design the closure approach, but once we get it right, it's interesting and it's faster. So there's something, another thing which we will come across again in strings. Okay, this is a template method. My understanding is the template method came out in either Python 2.6 or Python 2.5. I can be sure that it was not there well before Python 2.4 or whatever. But it's quite recent. In Python 2.6 and further, we find that it's used a lot. Okay, what it does is basically it has certain primitive or certain way of like displaying the keys of a dictionary. Okay, so look at this. Import string, string.template, the square of a number is the square. Okay. Now, for number in the range of 10, which will give 10 numbers, I am doing a square, which is again a Python variable, and number into number. Okay, again, these are like the number is here, number is this Python value, and the square is computed here. And what I am doing is message.substitute locals. Okay, locals is basically, so in Python, if you go underneath, everything is a namespace and everything is a dictionary. Okay, what's happening here is square is again your label, number is again your label, and each of them is a dictionary's key with the value of what we have during the execution. So you will have a dictionary with the key as number and the value as 1 during the first iteration of the loop. you will have the dictionary, the same dictionary, change with the key as number, with the value as 2 during the second iteration of the loop. You will have the same dictionary as number, key, and then the value as 3 during the third iteration of the loop, and so on. Okay, and each time the number into number will return the square of the number, okay, which will be again stored in the dictionary of the namespace with the key as the square and the corresponding value. Okay, I'll execute it and then I'll kind of show it with the whiteboard marker if someone didn't get. Okay, what it basically tries to say with respect to the string.template method is string.template takes a sentence and then you can denote certain parts of the sentence with the dollar character, okay, dollar some name, and it will replace the value of those keys from the value of the dictionary. Got it? So these are the important calls: string.template and then substitute. Okay, you create a string template you create a template basically. Okay, the simplest way I'll do something like this: str1 is equal to You got what's going on here? Okay, this is the simplest of examples which I can show you. Okay, I created a string.template with hello dollar something, and I created a dictionary with something as the key and the value as the world, and then I called the string1.substitute method and passed on the dictionary as an argument. Okay, so what the substitute method did was, it will look inside the dictionary of all the keys and then replace it with the corresponding keys of which is defined in the template. Okay, this is the property, and now we are utilizing this property to make something very interesting in the snippet. Okay, what snippet was that? 6? Yeah. Okay, so look at this. Here in this place, I am not defining any dictionary at all. So how is this? I'll execute this function first, and then you will see what's going on here. Okay, the square of 0 is 0, square of 1 is 1, square of 2. So it iterated over the range of 10 and then printed out the squares. See it's happening? How did it print out the square values when I didn't pass a dictionary at all? The dictionary is passed here, the locals variable. The locals is going to store whatever is contained here. So the locals variable will store. Locals is the namespace. Okay, locals is a function, the inbuilt function which returns the namespace, and the namespace is nothing but a dictionary in Python. And that dictionary will store the keys and the values of whatever the values and the variables which were executed till then. Okay, so you find that number is called from this function and the square is calculated, and then when you do a method substitute of that dictionary, you will find that it's properly getting substituted. Okay, there's a different way to do it where you can pass on the number and the square separately too. Okay, string.substitute. Okay, here I am not passing a dictionary at all. I am passing a keyword value pair. Okay, this is again something interesting in Python, that a dictionary is a mapping, correct? It's a mapping between a key and a value. Okay, so wherever you pass a dictionary, you can pass a mapping, and the mapping is in the form of a key value. So here is the key, which is a number, and the key should correspond to the template, whatever we defined it. And then in the mapping, we say that the number is equal to num, and then the square is equal to number into number. Okay? You got what's happening here. We didn't pass a dictionary. String.substitute expected a dictionary, but we are passing a number. We are passing a mapping. And a mapping creates a dictionary in turn, which we can use it here. So this is one of the use of string.template. I particularly have found it useful in some programming tasks where I have to pass an XML. Look at it this way. Okay, you have an XML file where name tag is equal to, within the name tag you will find the person's name. Okay, in order to best deal with those kinds of XMLs, what I do is create a template of the tag names. And once I pass the XML in the form of a tag name versus the value, I pass the dictionary to the template object, so that if I want to print it out, I don't have to do a multiple operations. Okay, I just have to create a template method with the name and the value, and the template will substitute the key with the corresponding value. Okay, this is something interesting. Okay, any questions so far?
How does this compare performance-wise? Is this faster string manipulation than the basic way to put numbers in strings?
Oh yeah, which one? The locals one or what? So the string.template is a basic, it's a recent addition in Python 2.6 and Python 2.5. I don't know if I'm wrong, but Python 2.6 and later. Okay, it's faster. It was, so what it tends to replace is basically the percentage operator which you used to do it, but it's more convenient, you see. You can explicitly pass on what you want to replace.
And you said it's faster than
Yep, it is. Basically, it's as good as any string methods, and it's typed in C, so it should be fine. Yeah.
Is there any security problem with passing locals?
You don't actually do it in the production quality codes. Basically, you don't. So locals are the execution dependent one, and you have to protect them. Okay. I don't know of any security problems because it is executed within that interpreter's session. I don't know of any security problems in passing the locals. But it's kind of not relied upon very much. Okay, it's usually considered a hack, basically, to rely upon a local, because you have to do it explicitly. Okay, this is something implicit. We are assuming that the function execution must have defined the dictionary, and they are using a dictionary of the locals. Okay. Yeah. As far as I know, there isn't any much security problem. There isn't, but it's not considered a good practice to use locals in the code. Any other questions? Shall we proceed further? Yeah. So this was a lot of examples with the strings. Okay. If I have to recollect, if you recollect, we first dealt with the Unicode and the ASCII, correct? We just saw that what's the difference, the basic difference between Python 3.1 strings and the Python 2.6 strings, which is Unicode and the UTF-8. We saw it with the help of a function. Okay, this tutorial notes, if you have it in the handout, will give you more details of whatever I'm explaining. We saw this function first, and then we looked at the translate method. Okay, basically, again, coming back to here, if you see that in the Python 2.6 function, which we looked at it worked on the translate of the characters, translation was a table lookup. Okay, but as translate usually works on a 128 characters, you have to make sure that the Python 3.1, which by strings is by default Unicode string, okay, it doesn't limit itself to 128. Okay, for the corresponding 8-bit strings, 8-bit characters, there's a data type by name bytes. Okay, look at it this way. You open a text file and you open an image file. The text file is also translated. Each and every character in the text file is translated into a sequence of bytes, right? When you open your image file, the image file is also a sequence of bytes in the disks, however you store. In Python 2.6, the image file was opened as a 8-bit byte string. Okay, each and every byte was actually, in Python 2.6, it was like a string object only, because the string served a dual purpose of representing a byte as well as a string. And in Python 2.6, the string was a 8-bit byte. Okay, in Python 3, a string is not a 8-bit byte. It's a Unicode. And the Unicode depends on the encoding. And depending on the encoding, it can vary from 2 to 4 to 6 bytes. Okay? And now, when you wanted to store something like or open something like an image file to represent it as a sequence of bytes, you have to have a data type to represent it as a sequence of bytes. And the bytes was the data type. Okay? And the string.makeTrans function, whatever was applicable to a ASCII string, was translated to the bytes function. So in Python 3.1, the same code was bytes.makeTrans and bytes.translate. And the byte string was denoted by prefixing the string with the B. It was added like during the transition phase only. Okay, bytes is nothing but a immutable object which is similar to a string in Python 2.6. Bytes is specific to Python 3.1. What it means is when you are reading a song using Python, or when you're opening a file like an image file, the underlying representation which the computer understands as a sequence of bits is an 8-bit byte. And the 8-bit byte is a bytes data type. Okay? When you're reading a HTML document in Python 3.1, it is not 8-bit byte. Okay? It is a Unicode sequence. So that's one. And then we checked if the string contains a set of characters. And then we looked at the reindenting a string. Okay, there's then multiple replacement within a string using substitute, and then template method. Right? Okay, let's go further. Let's look at files now. Okay, so any programmer has to deal with files sometime or the other. He will have to open the file. He will have to read the file. He will have to write a content to a file. And one of the interesting attributes which Python provides, open is the built-in for opening a file. Okay, it takes the 2 arguments. The first argument is the path of the file, and the second argument is the mode which you want to open. And if you recollect, there's an interesting one mode called RU, okay, which is not used very, very often. A variant of U is a precious RU, R with a capital U. And U stands for the universal new lines. Okay? When you want to make your programs portable across Windows, Unix, Mac, and whatever other operating systems which the Python supports, and if it has a different convention of denoting a new line, then better open it under RU mode. You don't have to deal with the new lines character. Python interpreter will deal by those. Otherwise, what it happens basically is like, if a file is from a Windows world and you open it in a Linux, it will find that funny cap-yum characters in that, and then when you are parsing it or doing some serious operations on it, that will interfere, and then your program will bomb. Okay, the problems, people kind of like translated the text, remove the \n characters, and do whatever they want. When they're checking into a perforce or a SVN location, they make sure that it is universal new line. Some people adhere to basically having a single kind of a new lines in an entire source code files. Okay, apart from that, these kinds of functions are also available, where you want to open them in a universal new line format. Okay, also, what is a good strategy for reading a huge document? Okay, for example, your computer has a 2 GB memory, and the file which you want to read is of say 10 MB. Okay, so what's a good way to read a 10 MB file? The best way to read is like loop over it chunk by chunk. Okay, and when you read with a size of say, and when you read with the size which you specify for the file chunk is basically a power of 2. People do it like, for example, 4 blocks. Okay, which is like either say 1000. So it has to be a power of 2. Okay, read it, say for example, file.read 1024, which will read 1024 bytes of the file, and then you do it in a while loop. Okay, so at that time, the read will basically read the 1024 bytes of the file and then go on till it encounters the end of file character. Okay, so this is one of the strategies to read a huge file in Python. Otherwise, you are going to be limited by your system memory. So this is where it says that the read is called with an integer argument n. It reads and returns the next n bytes of the file. Okay. files have other writing related methods, basically like, so when you are writing to a file, you might need to. So you have got the data over the socket and you want to write to a file. Okay. The data is continuously arriving, and when the write operation is called, you kind of like it's stored in the memory. So you want to write it in the disk, you call the flush, which basically removes the content from the memory and writes to the disk. Okay. So read, and the read with an argument is an important task. When you are writing, you write and then you flush, basically to remove all the content from the memory to the disk. And and then there is seek and tell, and then some random seeking, random. So seek will basically seek to a particular location in the file. So there's a seek call and a tell call, which will, if you want to randomly access a particular character from a file, want to go to a particular byte, you do a string.seek, okay, file object.seek. It will go to a particular location in the file. Okay. When you want to deal with a file, what Python's duck type nature, which determines is, it need not be a file at all. Okay, it can be a file-like object. So what do I mean by a file-like object? A file-like object is something you can read. Okay, that object provides a method for you to read. An object provides a method for you to write. Okay, or let's stay with the simplest of file-like object. If something provides a method for you to read, or if something provides a method for you to iterate over, just like file can be iterated over, it is a file-like object for our purposes enough. Okay, that's what the duck typing is. In Python basic courses, we all learn that the duck typing about. So if you have a string, but you want to pass a file-like object to a different place. Okay, for example, your zip utility or the zip function expects a file-like object. Okay, you cannot pass a string to it. So you can create a file-like object using a string.io module. The string.io is a Python standard library module which takes a string and then returns a file-like object. And with the file-like object, you can read it, you can open it, you can close it, you can operate it as if it were a file. Okay, so that's file-like object. And just like the file object provides a read lines method, where you can read all the contents of a file, and then the read lines will return a list of the lines in the file. It also provides a write lines method. Okay, and the write lines will take a sequence, a list, and then iterate over the contents of the list and then write to a file. Okay, the reason I'm mentioning the write lines method is, when you read the Python documentation tutorial, you will most likely skip past those things. Okay, most often we will care for reading a file, and sometimes we will write a file using the file.write. These are the two methods which we'll use often, read and write. Okay, but these interesting methods like read lines and write lines are available, which will ease our tasks to an extent and are of course faster than any other way we do it. Okay, if we are to write it on a file, if you have to write a sequence on the file, you will see that when you are starting with Python, you will loop over the sequence, like for item in a sequence, file.write item. Okay, which is looping over the sequence and then writing the item explicitly. But if I use this function by name file.writelines, pass it on to pass the sequence to it, the write lines will in turn do it. Because it is inbuilt into a file object, it is probably faster. It is faster than looping over the sequence explicitly. Sorry. So there's a zip file module which can be used for handling the zip, basically like your .zip files. Okay, it takes a read and a write arguments, but you don't have to specify the mode that the file is going to be binary, because it assumes that it's inbuilt is going to be a binary one. Okay. Now have a look at this function. I'll just get back. See, the task is reading a single line from a file, given a line number. What's a good way to do it? Okay, you are given a file, and then I give you a line number which is 42, or say 101. You return me, you give me what is that particular line is. Okay, you can do it in a number of ways. What you can do is like, because file returns an iterable, you can loop over the contents of the file, keep counting the lines 1, 2, 3, 4, 5, and then when the line number is 42 or say some other line number, you can print that line or return that line. Okay, that's one way. But there's a line cache module available in the Python standard library. Okay, which basically which is faster than the enumeration because it doesn't have to loop over it. It's coded in, okay, it basically abstracts away that getting of the file, getting the particular line in the file. Line cache has a getLine method which takes the file as the first argument and the number of the line as the second argument and then returns the line. Okay, so this is a Python 3.1 function. And another difference in Python 2.6 and Python 3.1 basically is in Python 2.6, whenever you're writing Python 2.6 code, print is a statement. You don't have to put up the parentheses around it. Okay, but in Python 3.1, it's a function. You have to call it like a function. And then the first argument, which will be like a output, and the end argument which you want to give, the terminator, which if you want to give a space or a \n or a \t, you can give it as an end argument. So these are the two methods. Okay, the line cache was one method, and then iterating over the line. Look at this. I give you a line and the desired line number. Okay, if the desired line number is less than 1, which is like I give you a 0 line, I don't count the lines with 0. Okay, I count with 1. So I return, I don't have a line. So, but otherwise, what I do basically is like open the file in the universal readline mode, and then I enumerate it. What the enumeration function does is it returns the iterable and a number. Okay, it returns 2 values. So that is why it is returning a current line, number, and the line. Okay, current line is basically a current line number. Okay, it returns a number of the sequence and the element of a sequence. And then if the current line is equal to a desired line number minus 1, because the list sequence starts with 0, I have to do this. Okay, in Python, the sequence or a list starts with a 0. So even if I wanted to get the first line, okay, I would have given the first line number as a desired line number 1. 1 minus 1 is equal to 0. The list would have given the first line as a 0. So that's why the 0 and 0 will match and will return the first line. Okay, you're getting it? So this is one simple way to do it. So here's the example. Yeah. So it looked for a file in the Fortune database, and then returned a particular line from that file. Okay, these are two ways to do it. Okay, so now what modules did we use? We used line cache module, correct? And we also worked on the enumerate built-in function. Okay. There's another task. Now, the task is to find the files given a search path and a pattern. Okay. You give a path, a directory location, and then you give a pattern. You give a pattern that the files which start with a number, the file names which start with a number, or file names which basically end with .py, all the Python files. Okay. How will you find all the Python files in a particular directory? Okay, you can do if you are using Unix or Linux or Mac, you can do a find, you can do a grep. Okay, but on Windows, how will you do that? Okay, you will have to. Windows has a search feature, but it's not a regex-based search. I don't know if it's a regex-based search feature. Okay, this is how you will write it in Python. Okay, now we are going to see the two modules which are called glob and OS. Okay, glob, GLOB, is a module which takes a pattern and will return a list of files which are corresponding to the pattern. Okay, glob module is used basically for those purposes only. Yeah. So let's look at this again. So I have for match in all files star.py get os.current working directory. Okay, the OS module has a method by name get cwd which will return the current working directory. This is our path, and our search pattern is star.py. Right? What I aim to do in this is in the current path I have to find all the Python files. I'm passing the current path, and I'm passing the pattern which is star.py to this function by name all underscore files. Okay, which is taking a pattern and a search path and an optional argument path separator. Path separator is again a kind of separator which your operating system will tend to use. Windows uses backslashes, Mac and Unix uses forward slashes. Okay, if you want to change some other path separator, you can define it too. Okay, so what it uses is, okay, it takes the path and then okay, for match in so it takes the search path and splits it based on the path separator, and then looks at all the path. So look at what it has done. I passed the current working directory, okay, and then it took the current working directory and then attached every file of the dot star nature and then returned the path. Okay. So the glob module will look for the current path in the current. So glob module will basically create this. So os.path.join path comma pattern will join the path with the pattern in the format which is understood by the operating system, and it will give all the files which are matching the pattern. Okay, so the point here is usage of the glob module. Glob.glob star of py will return a list of files. So here it is. So this glob.glob star.py will return all the Python files with the files which end with .py. Okay, what I've done is I've done a join of the path with the list which is returned, and then I've yielded them. Yielded them will return like a generator expression, so I'll get one file at a time. Okay, so this is what is happening here. All the paths, all the Python files in the current working directory is like obtained using the all files generator method because it's yielding it. Okay, and it's good to use a yield and a generator in this case because if your particular file contains say 10 million files, okay, and and if your machine is like a very low-end machine which cannot separate 10 million items in memory, you can still use this because it is a generator, and generator will load only one item at a time, so you can still use. Okay, if you had return it using a list, you may not because it's loading entire 10 million items in the memory at once. Okay, so this is one way to find all the Python files in the path. So this function, this how-to elaborates on glob, OS, generator expression. That's it. 4 or 5 things here. Okay. Okay. So as I said, how will you create a file-like object from a string? This is the method. Okay, string IO provides a functionality to create a file-like object. So look at this. Start here. This is my string. 1 \n 2 space some characters \n 3 \n. I want to create a file-like object using this string. So I pass it on in the string IO module. Okay, the string IO class basically. The string IO class will return. The string IO will return a string object, okay, which is basically a file-like object. So to test it as a file-like object, I have defined a function by name of scanner. Okay, the scanner takes a file-like object and then does a takes another function as a line handler. On a file-like object, I iterate over the contents of a file. For line in file object, I pass on the function which is a line handler. What it is doing is basically it's splitting the line of a file into 2 parts and then printing the first part. Okay, following it? So when I execute this function, okay, so look at this. We got that this is a string IO object and then of type C string IO. Okay, what I'm showing here is actually a Python 2.6 file which has a module by name C string IO, which is like a C implementation of a string IO function. So string IO is nothing but passing a string as an input-output object, as a file-like object. Okay. In Python 3.0, that was replaced. The C string IO was replaced with the IO module, which was in Python 3.0, which was implemented in Python, which tend to be very slow. And then Python 3.1 onwards, this IO module is written in C itself, so it's fast. Okay, and that's why Python 3.0 is kind of deprecated. That people are not advised to use Python 3.0, but Python 3.1 is, because this is one of the underlying layers of the Python the Python interpreter and the basic usages. You pass on the file-like objects tossed around often, and when you have this underlying layer which is slow, you don't want the performance of the Python to be slow. Yeah? Okay. So this was one of the use of the file-like object. How to 8. Yeah, this is what we saw. Okay, so if you look at this, it is taking the this was taking a string object. Okay, the scanner function was taking a file-like object, and for each line in the file-like object, it was calling this line handler function, and the line handler was nothing but this first word function. Okay, the first word will split the line will return a list of all the words of a sentence, and in that it returned the first argument. So you will find that 1, 2, and 3 returned. 1, 2, and 3. So you got what's going on. Okay. C string object is created, passed on like a file. You iterate over a file, and on each line, you basically create it in a form of a list of words, and then print the first letter of the word. Okay, we'll see one more, and then we will go for a break. So how will you create a zip file in Python? Okay, you are given a task of uploading. So basically, you are developing a web application, and then someone uploads a file on your web application. What you want to do is basically convert that file into a zip object and store it, because zip compresses the file. Okay. If you want to code that web application in Python, how will you do that? Python provides the zip file as a standard library module. Okay. And the zip file takes the file name as a first argument, and then what you want to do that as the, you want to write to a zip file, then you have the mode which you want to do it. Okay. And whatever you want to write as a write string method in the zip file. Okay. It creates a zip file in the form of a zip file. You write a string to it and close the method. Okay. This is for creating a zip file. Okay. That's it. You have a zip file object, which you can use some other utility to do it too. This particular script tries to demonstrate something more than creating a zip file. What it tries to demonstrate is basically you can have a module within a zip file and then import that module from a zip file. Okay? So this is what I'm trying to do. So for example, I created a module hello.py inside a zip file, and I put that zip file in the front of my path, and I can import that hello. Okay? Hello is created here only, and which is inside a zip file. Okay? I can import that hello function here, and I can call the function which is defined inside the zip file by hello.py. And os.unlink is the removing of a file. Okay? If you want to remove a file in a good way, os.unlink is the method. And this Python snippet also demonstrates another facility of creating a temporary file using this module by name temp file. Okay? Temp file.makeAsTemp, which can take an additional argument, basically of the extension what you want to create. So it creates a temporary file by name something.zip, and then using this temporary file name, I pass on that. So the temp file creates a file handle and a file name. Okay, it creates an open file handle. I want to close that file handle and use that file name as a zip file argument so that it creates a zip file. And inside that zip file, I want to write a Python module by name hello.py with a function inside that. And then I want to insert that particular zip file in the front of my path and then access the module directly from the zip file. Okay, 4 things going on here. Yep. First we saw is creating of zip files, which is easy. Zip file.zipfile, the name of the file. Okay, the second thing is you can have a Python module within a zip file and then use that Python module, which is going on here. Okay, these are something which I do extra because I want to have that path of the zip file in front, because otherwise it will search for the standard path. Okay. Other is like some simpler functions like creating a temporary file, which is using the temp file module. Okay, let's see how it works here. Yeah, so okay, it called hello.py from temp file.zip, and within temp file.zip there's a module by name hello.py. Yeah, this snippet tried to demonstrate it. That's it with file handling. Let's go for a break, and then my thought was we will be completing till processing XML, but we'll hurry up after we come back and then try to concentrate on date time processing and dealing databases. And if you want me to basically concentrate on one section more than some other section, let me know. We will adjust for it. Okay, thank you. Shall we go for a break now? Fine. Thank you. Okay, so I think I have to pace up a bit because we have many things to cover. Okay, what I'll do is I'll cover the important stuff in detail and then give an overview of the others because this is available. And the aim is basically you get familiar with the code. Okay, so that when you work on the code, you have that kind of a familiarity to work further. To catch your attention, let's look at some interesting snippet, something very interesting with respect to Python. Okay, there is a time it module. So look at this source code. It's not a Python source code. Okay, it's a shell command. It's a command. Okay, I'm giving a full part of Python 2.6. You can just give Python 2.6 if it's in the path. -m time it. -m is a command line option for the Python interpreter. Takes a value which is a module name, -m time it, and then -s takes the source code. Okay, so if you see that in the first sentence, okay, it takes an import random, and then creates a random list of 1,000 integers. It shuffles them. Okay, so this is a one argument because, and then it creates a list of all those random integers and then sorts them. Okay. So what I am doing is I am measuring the execution of this Python snippet using a time it module. The second line is doing something very similar. What it is doing is instead of assigning it to a list and creating a new list, okay, what I am doing is I am doing an in-place sorting of the list. Okay. The third basically is using a sorted function. Okay. Sorted is a function which will return a new list. So I am not doing an in-place sorting. Sorting is something we understand, right? If a number is arranged, you can sort it using descending order and ascending order. And by default, this is a ascending order. Okay. So the source code here, I import a random module. I create a list of 1,000 integers, and I shuffle them, and then I am sorting it. I am doing a sorting based on different functions. First is y.sort, a list.sort. I am creating a list using a list already obtained, and then I am calling a list.sort. Every time it's a new list. In the second example, I am using a built-in sort on a already available list object, which is doing an in-place sorting. Okay, the list object is available, it will do an in-place sorting. And the last example, I am returning a sorted list. Okay, so the last example will not print a list because I am not capturing any return value. Sorted will return a sorted list. Okay, I'm just returning a sorted list, but I'm not capturing it. Let us see. These are the three ways of sorting it. What I have done is I have tried to measure the performance of these three methods. Okay, let me execute it and see how it measures against it. Sorry. Because that was not a Python source file, I cannot do a Python on that. So okay, look at these two values. Okay, the Python time it module, when it executed using in the command line option, it has certain heuristics to run the many loops it wants to basically capture the best case conditions. For the first test case, it executed 1,000 times, and then it measured a best of 3, which gave us 255 microseconds per loop. Okay, each loop of sorting of 1,000 integers took 255 microseconds. Okay, the same was with the case with the other loop too, which was like 259 microseconds. So almost same. But something interesting is going on here. No matter how it tests, the best of 3 gave 18.5 microseconds per loop, which is way, way, way high. Okay, which is 1,000 times, yeah, 10 times faster. Okay, 10 or 20 times faster. Okay, so what's going on here? We have just called the sorted and the sort. sort is a method available in the Python's list. Okay, for example, I create a list one of range of 10. Okay, import random.shuffle. Okay, I have this. So you see this. I have the list one, which is a random order of integers. Okay, I will I'll do a sort on that. It's sorted now. Okay, I'll do the same operations on this list one. Okay, shuffle. Sorted of list one. Okay, do you see the difference here? The first one was an built-in sort. Okay, inbuilt sort. So that's why it created a sorted list. Okay, the second one is a new list. That's why I had to print it. If you see the list one, it won't be sorted. Okay, a sort method on a list object does an inbuilt sort, and a sorted function which takes a list object returns a sorted list. These are the two kinds of sort facilities available on the list in Python. But what can explain this kind of a difference? That one of them is 20 times faster. Okay, what's going on here is this list. Okay, so if you're from if you recollect the computer science background of sorting things, there are different algorithms available for sorting. The very basic ones of bubble sort, to a heap sort, to merge sort, and different kind of algorithms are available in sorting. And Python uses some kind of algorithm, which is a merge bit, which is a different kind of a quick sort and a merge sort together. That on an already sorted data, it works wickedly fast. Okay, so in the second thing where x.sort is called, the data is already sorted. And when it's trying to sort an already sorted data, it recognizes the pattern that the data is already sorted. And it works so fast that it's 20 times faster. Okay, that's called as timsort, implemented by Tim Peters. So here you have, in the Python subversion itself, it is explained that what is the list sort basically is. It's called timsort. And this is a Wikipedia page on the timsort, which explains that this kind of a sorting algorithm came in from the Python, and it's been adopted to Java too right now. Okay, because it's something which is like very interesting. In best case performance is basically like order of n, which is like number of lists. You find some patterns in the data, it exploits it, and then does in a very good way. Somewhere it's mentioned that, yeah, algorithms instead of thing, it's now used in the Java arrays in Java 7.2. Okay, so this is something interesting which I came across, so it's worth sharing too. Yeah, and yep. So as I shared about the timsort, I kind of like walked you over the different kind of sorting methods available, which is list.sort and the sorted. And now I also demonstrated how to use a measurement. If you have a piece of code in Python and you want to measure it, okay, how do you do it is Python -m timeit module -s the source code. Okay, and within the source code which you are putting inside the -s the codes, okay, you can pass two codes. The first quotation is something which is an initializer. You don't want to test it again and again. Okay, in these basic functions, so if you see this, the first quote ends here. Okay, the first quote ends here at this place where my cursor is, and later on this function comes. So what we are measuring is this particular portion only, which is what we want. Okay, we want to initialize the list once, and then we want to measure the sort functionality. Yeah, so you understood how to do it in timeit. You create it in the form of a two arguments. One is initializing the list, and then you have the actual code which you want to time or measure it. Okay, so that's what there. Now let's continue with our tutorial session of let's look at the when you are handling when you're developing web applications and you want to deal with some datetime related tasks, what's the module available to you? Okay, There's a standard library module called datetime, which helps you to deal with date and time properly. And then there's a standard library module available called time, okay, which helps you to deal with the granularities of the time. Okay, so both are very interesting. So when you import time and when you get time.gm time of 0, time.gm time converts any timestamp into a tuple without a time zone conversion. So this time module has a support for time zone conversion too. Okay, let's come back here later. Let's look in here first. Basic datetime handling. Look at this snippet, the first one. Okay, import datetime, datetime.date.today will return the today's state. It will depend on your current system's datetime model because it has to use the C library to query the system time. Okay, but what it provides basically is an abstraction for you to deal with the dates back and forth. So if you want an yesterday's date, okay, you can subtract today with the time delta of 1 day, minus 1 day. Okay, so it was yesterday. And if you want tomorrow, you can add today with a time delta of plus 1 day. Time delta will move your datetime object to as many days which you want. And the days is not the only function. Okay, you can have months, years, too. So if you want a time delta of 1 month, what will be the day time object? You can use like time delta dot months is equal to 1, which will move forward your months detail to 1 month, and then you can have it here. And here, this is, so datetime or datetime module provides you a way to deal with the date and time object together as a date, as a one method, okay, one object. Look at this one. Okay, datetime dot date.today, which is today is a convenience function available to you. They will return today's date. Okay. Now, when you pass datetime.date any particular year, month, and a day, it will return that particular year, month, and a date as the date object. Okay. So you have a birthday, which I have given some particular date as a birthday. It will prevent that. Okay. Now, if you want the current time, datetime provides convenience functions. For example, datetime.datetime.now.time, which will be the current time. If you want to specify a particular lunch time, then you have datetime.time, give the time as it, which is a lunch time. The variables which I use is like you can use anything you want. Okay, it's a convenience because you don't, in Python you don't have to declare a particular variable. you can use anything. But the important point is the methods which are available on the datetime object. Once you create a datetime object, and I hope you know how to see the methods available on that. Okay, it's simple. Import datetime, dir of datetime. Okay, so the datetime provides these methods. For example, max year and min year will be a constants. That's why it's stored in the capitals. The under methods are special methods which you don't use often. Okay, you just have to understand them. You override it only in complicated situations, but you don't touch them. Normally in many programs, except for say you write a program to interpret a program. For example, you want to write a parser, you might have to look at the doc strings of the method. Okay. Otherwise, the datetime, datetime C API, and datetime and time delta are the methods available, and you can do a help on datetime.time to know specifically what the time class is supposed to do. And this particular example shows that datetime.date.today gives a today's date, datetime.date on a particular date will give that particular date, datetime.datetime.now will give that time. Okay, if you want to create a new time based on a futuristic time, you can pass on the year, month, date, time on that, and you will prevent the futuristic time. Okay, and I was surprised to know that there's a particular RFC format for defining the time, which is RFC 1123 in a particular date format. Okay, so you can define 2 date formats in this particular format, and then you can basically strp time will read that particular will interpret that particular date time in the format which is specified here. The format is explained in the Python documentation. So if some two different formats of dates are available, how will you compare that those two dates are equal? Okay, you don't want to do a mathematics on that. It's difficult to do a mathematics to basically find that how many days have passed between these two dates. Okay, you have to convert the days and then months and days and all together. Best is create them into a datetime object. Parse the datetime in the form of a string parse time based on the format specified. Create the datetime object, and then use the Python's facilities to compare between these datetime objects. Okay, if the two dates are equal, print them as equal. If one date is greater than the other date, greater. So what it means to say is a formatted representation of a datetime string can be converted into a datetime object, and you can deal with them like a datetime object. Okay, this is helpful when you are creating a calendar application or you are creating a mail application where you want to schedule a meeting and all those things. You might have to deal with the datetime module. Okay, apart from that, there are third-party extensions available like dateutil and mxdate, which are helpful. Okay, so there's the Python package index where you can find all these datetime, the third-party extensions. Go to the Python package index, which is pypi. Search for these, and you can download the form of a tar.zip, or you can install it in the form of an egg file too, which is a distutils files. Okay, it's a different way of installing the Python package utilities, but you can install them, and then they also provide a convenience functions. Okay, the whole point of this is how convenient it is to handle the datetime. Okay, so let's look into the processing XMLs. Okay, so this Python 2.5 onwards provides a way to process XMLs in the form of a tree-like object. Okay, again, I want you to recollect the computer science concept of a tree data structure. Okay, your tree is your node and the children. Yeah, so you can find all the children of a particular node. Okay, this is a HTML document. So I had to think of a HTML document in the form of a tree to understand this module's functionality. Okay, HTML documents usually are written in the form of this. Let's so look at this HTML document. Okay, I just generated it. You see that it's a head, and head should have a corresponding closing tag in the form of a head. Okay, and then the HTML tag. Did I remove this? Where is it? I think I removed it by mistake. Okay, the starting HTML tag should have a corresponding end HTML tag. So HTML is nothing but the syntax of these kind of a markup. I hope everyone knows. But how do you look at it in the form of a tree is the question. Okay, you have to visualize this HTML document in the form of a tree with the nodes. The root of the tree is the HTML. Okay, it has two children, a child by name head and another child by name body. If you see this, head is here is another child, and there is this child by name body. Okay, the head child again has another child by name title. It has two children by name meta and meta. Okay, this body has a child by name br and font. So visualize the HTML document in the form of a tree. And the Python elementary module is doing the same. It parses the HTML document in the so you can deal with the HTML document in the form of a text file. It's not so interesting. But once you can format it and create a tree-like object to it, you can basically find the child of a particular node. Okay, just hold on. So that's where it gets interesting here. So parsing an XML tree, XML using an XML.eTree module, which is elementary is a third-party package, but it's been a standard library package from Python 2.5 onwards. It parses the HTML in the form of a tree, which is HTML head meta. So now, once that HTML is parsed, look at it how it's doing it. Okay, from XML.eTree elementary, import elementary. Elementary is the class which is converting the HTML into a form of a tree. It parses the index.html tree, and it finds body/p. What it means is find the body tag and the child called p of the body tag. Okay, p stands for paragraph. Okay, so it has found the correct tag within the HTML content. It has directly jumped into the object. Okay, now for that paragraph tag, get an iterator of all the anchor tags. A is again an object. A stands for an anchor. So it creates an iterator of all the anchor tabs, and then what I'm trying to do is, it must have created a generator object. Okay, so I can loop over all the, iterate over the iterator, and then I can replace the attribute. So the XML formats one of the values attribute, okay, the target to be blank, and I write the tree because I loaded the entire index.html as a tree object. I processed the XML file, added a target link, target attribute to it. I can write it back in the form of an output.xml. Okay. So there is index.html, xhtml. Okay, it has an HTML tag, example page. Here's a paragraph, and inside the paragraph, I have a reference element, example.org, a reference element, example.com. I will basically use that script, which is how to, should be 15 or what? 13? No. Yeah. So it parsed the index.xhtml, finded the paragraph tag, and created an iterator of all the anchor tags, looped over the links of the anchor, and then created a target attribute for each link. And in the target attribute, I replaced the value called blank, and then wrote that tree object to an output.xhtml, which creates an output.xhtml with these contents. So when I run this file, you see that the paragraph element was found, which is the p tag, and it created a list or generated a list of all the anchor tags, and then it must have written the output.xhtml with the target is equal to blank. Okay, you get how you deal with the XHTML, right? So elementary module helps you to deal with the XML stuff, handle them in the form of a tree object, and if you look up the documentation of the elementary, you will find that you find all the tags for a particular tag value, and then iterate over them and process them. Okay, yeah.
The tree parse argument or the tree find argument is body/p. Why isn't it not HTML/body/p?
Oh, it can directly look over. It finds it. It's a find option. It's a find.
I tried p and it's giving me an error.
Pardon?
Just p would give me an error.
What kind of an error?
None type.
Let's see that. Oh, okay. So it basically, it has, so when you find that xml.parse xhtml, it has basically found its location is located at the root of the tree. Okay, it has to find from the root till the next, and body should be available within the root. So it is in this, so it should work. I don't know why. So. It didn't find the first P. So it is trying to find the first P object within the root object. So it is not finding a P object. It has to find the P root within the body object. So it has to find the body, and within the body tag, it has to find the P. It has to go one level deeper. That's why it is finding a none-type object. And when the none-type object is returned, it's not finding it.
So HTML is the root?
Yeah, HTML is the root. Yeah. That's to deal with the XML. Okay, that's very convenient way of dealing with XML, believe me. There are various different modules available for XMLs, and one is a LXML, which is kind of an interface, which has an interface to the elementary too. I'm not sure about it, I've just heard of it. But as far as I have used, elementary is a flexible object. It's a flexible container type and has a lot of methods which help you deal with XML. Dealing with databases. Okay, so any serious stuff programming will involve using database. And Python has various different connector objects, basic modules, which provide support for big databases like Oracle, MySQL, PostgreSQL, and all those. Apart from that, from Python 2.5 onwards, very lightweight version of a database called SQLite 3 is shipped with the Python 2.5. So how will you create a database is, you create a database object, a connection object by SQLite 3 connect an example database name, and create a cursor to the database, which is nothing but a pointer to the database by calling the connection.cursor. And then you execute any SQL statement on that, on that cursor object, which is c.execute, create table stocks, date, transaction, symbol, quantity, and oops, I have to fix power to my laptop. Just hold on. I think laptop power is running out. Yeah. So you create a connection, database connection, and create a cursor object, which is a pointer to the database, and execute the SQL statements. You just have to know the SQL syntax to create a database. So here's a simple, tiny example using the SQLite database itself. If you have installed Python 3, Python 2.5 on extra, so you will have this SQLite already available, which should be So this was an SQLite 3 format database, which will store the values into that. So that was a simple example of how to use the SQLite database. Okay. So in order to serialize the data, so for example, when you are passing the data around over the wire and you want to store it in the form of a compact representation, it's called serializing. And when you want to retrieve the original data value back, you have something called deserializing. Java people know them as a serializer and deserializer. In Python, we call them as pickle and unpickling. There's another module, related module called Marshall, which kind of like stores a serialized format. But that's usually used with creating a Python file to the .pyc file. Okay, pickle is the one which you have to use. Any Python object can be pickled. Most of the Python objects can be pickled. And these are the various objects which can be pickled. When I mean by pickled, it's compact representation, and and it has certain, and it works across the particular versions only. Okay, so if you pickle a Python object using Python 3, you cannot unpickle or deserialize it using Python 2. Okay, you have to use the same protocol versions for using the pickle and unpickle operations. And, and using the pickle and unpickle is very easy. You have to dump the Python object as a pickle. So here is an arbitrary collection of objects supported by pickle, which is a dictionary of strings. I have a different form of an integers, and then there's another with the character string and the byte string, and then there's a set data type of different keywords. For example, none, true, and false. I use a context manager for creating a file. Okay, what I mean by a context manager is when I open a particular file as f with keyword, okay, I am opening the file, and when this statement is finished, it will automatically take care of closing the file. Okay, I don't have to explicitly close the file. So that is where I mean by a context manager. So, so I'm creating a data.pickle in the form of a write binary file, and then I pickle.dump the data as a file object with the highest protocol which is supported. So this would have created a data.pickle file which I can pass over the network, and then someone else can use that data.pickle file, read them back, and then create the entire Python object back for them. So here is what I must have created a data.pickle, right? Yeah. So this was a pickle data which was stored in, and then that's the retrieved data available back from the pickle. Okay. Sorry. If I create some long. Yeah. So we looked at after the break, we looked at date time, how to deal with the date and time, and then we looked at the XML, like parsing the XML in the form of a tree object and then iterating over the tags of the XML tree as a form of a tree. And then now we looked at database, connecting to a SQLite database and then executing an SQL command. And then we also looked at a pickle, which is like creating a persistent data store of the Python statements and then pickling it and then unpickling it back. Let's look at the subprocess. So, so before Akamai, I used to work at Dell, where we used to use Python during the automation. Okay, with the automation, when we had to test BIOS-related functionalities in the Dell laptops, we used to execute a command and then see if so for example, let's set the temperature of the sensor to say 10, okay? And then you do some operations and then get temperature sensor value is what we are doing, executing the command. And we want to verify back that the particular operation did not heat the laptop very much. You want the 10 to be compared against the 10. Okay. For those command execution, we have to execute a command on the system, right? So we used to use the subprocess module. It's basically a command execution module. Any command you give to it, it will execute it. It will give a handle of the handle by mean the process handle of the command which is being executed. And then on the process handle, you can query what the output of the command was, what the error of the command was. And if you want the command output to be stayed in a particular state, you cannot control the process. You can basically get the process's output and the error values. And that's what we use to subprocess. And you can compare the output using standard Python comparison operations. So here's a basic example of using the subprocess module. Subprocess.call is a convenience function which is provided, which takes keyword arguments, a list followed by a dictionary, a list basically, which can execute whatever you specify as a keyword directly on the shell. Okay, so look at this. OS.system will execute any system command. Okay,
So the way to do it in subprocess is subprocess.call
So subprocess.call with the function which you want, the command which you want to give. Shell is equal to true, the command will be executed or interpreted by the shell. Okay. So the subprocess.call has, when you give shell is equal to true, it can interpret the shell variables too. For example, in this location, I am passing on the path. So this path value is got from the shell. So this path is interpreted by the shell. If I don't pass shell is equal to true, it will not find the path. Okay, it has to be executed by the path variable only. So subprocess.call is the convenience function of os.system call. Subprocess provides a class by name popen object, okay, which can return a process and you can communicate with the process. So this same function which I did, I wrote it in the form of a subprocess.popen echo hello world, shell is equal to true, and the standard output is a pipe. Okay. When I mean standard output, I want the standard output to be redirected to the object here. So I created a process object, and when I created a process object, I can communicate with the process object. I can send values to it. I can retrieve output from it, and and when I pass the standard output as a pipe, whatever I get in the first argument is actually the output. Okay. So this will give the hello world output. Look at this other way, where I pass the standard input object as a pipe, which means that I'm handling the standard input object. I can communicate it using I can send values to it. I can send values inside the process object. Okay. Here, I pass both standard input and the standard output, which means that I can send value to the process object and I can basically retrieve the output too. Okay. And subprocess replacement of popen3, where I can send an input to the process, get an output, also an error, and then I can handle the both output and an error. So these are the methods, or these are like basically the templates available for using the subprocess. When you are writing a particular program where you want to execute a function on a system, you recollect the subprocess module and the way to deal with the commands on it, and you pass those commands by handling the input, output, and the process. Okay, you have a handle on the process. That is the most important thing. os.system, it gives to the system and it executes. You don't have a handle. You can execute. You can basically create a subprocess object here. Way down sometime later, you can call process.communicate. Okay, it will get called only when you communicate with the process. The process handle has already been created. You can communicate with the handle and get the output and the error. With respect to os.system, you don't have a handle of the process. You just basically throw away the command and let the system to execute it. This is one feature which is provided by the subprocess. So here is the example which printed out the standard output. When you write to a standard output and then print it out, the way to deal with the error message and the standard output. So a scheduler. So if you want to write a scheduler, for example, at every 10 seconds you want something to be printed, or every 1 second something to be printed. There's a standard library module available by name SCHED, sched. Okay. And the scheduler is like it enters a particular state and then performs a command. Okay. So concentrate from here. The main will take a command, and then it will enter a particular scheduler state in 0, 0 and perform a command. And the perform command is nothing but a function which takes the command and the increment. The scheduler enters the increment value, and it executes the command. Okay. These are the scheduler primitives, where you want to enter it to a particular value, and then execute the particular command. You can do it in some other way too. Do a while loop and sleep for some seconds. Sleep for every 10 seconds and execute the command, which is some kind of a scheduler. But this has a better advantage that it's kept track how many times it's executed. Okay, it's as the while loop is a busy wait loop. It kind of hogs your system. This one will not. So it schedules in the form of it takes the time basis and then runs it. It doesn't hog the system of continuously looking at it. So this particular example, the scheduler will work for, say, 60-second basis. If I give 1, it will run every second. That's why you see that. And you can give the other things too. So let's look at this function from this point onwards. Sys.argv will give the number of arguments I give on the command line, and I determine that what is the length of the command line arguments. If it is less than 1, which means that I didn't give a command itself, I want to print an error message. If it is greater than 3, which is like I gave a command, I gave a number of times it wants to iterate, plus some other things, I recognize it as an invalid command, so I give the wrong output again. If it is current, so if it is only the command is given, I call the method with only the command, which will make the scheduler enter to perform the command, and in the perform command, it will enter the increment second and then execute the command. Okay. The primitives of available are that is this scheduler enter with this. Scheduler object is the, which is basically a object of the schedule module, which keeps track of the command and how many times you want to execute. Okay, it works on the time basis too. It's much better than, say, looping over the while loop and then counting the seconds or times you want to execute. Okay. Let's look at one bad function of monitoring a particular directory. Okay, again, it's a scheduler function. This is something which I had written myself for some task. Okay, this is a big file. I'll explain to you what it's doing. My task was to constantly monitor if a new file had come in a particular directory or not. Say you are writing a server, and that server is constantly getting new files. You are monitoring a particular directory for any changes which are coming up. So I wrote this function, which was a while loop. Okay, here it is. A while loop which will constantly monitor for any changes which is occurring inside a logs directory. Okay, how do I do this? I will use the I will do a list directory of the directory locations. Okay, I'll list the contents of the directory, create a set of all the contents, and then look at the access time of files of the directory. It's simple. You have a directory, monitor the directory of all the files, read the file's attributes of what time the last file was accessed, what time the file was modified, and if there is any difference between the file access time and the file modified time, you say output that yes, it was modified, it was touched. Okay, that's one way. It seems fairly straightforward way to do it. Okay, but the main drawback of this is it's a busy wait. So you will see that this kind of a program is like hogging your system constantly looking for a particular directory. So okay, I have executed the program and it looks for the logs directory. Where are we?
26. This program, when I created a new file, it said the new file. Okay, I will update that existing file. So it says that it has updated the existing file. Okay, I'll create a new file. It's creating a new file. It has recognized the new file again. So it has constantly monitored a directory, looked at the file attributes of the files inside the directory, kept a dictionary of what the file attribute values were, and then it's working on that. But look at the drawback of this program, that look at this memory consumption. It is taking a fair amount of the CPU time. Here it is, the Python process. If you see this, it's taking 100% of the CPU. The reason is it's a busy wait. It's constantly doing something and it's keeping the processor occupied, which is not a good way to do it, right? I mean, if you do some kind of an operation like this in a busy wait loop, you are not allowing a system to do something else, which is a bad way to program in any case. Okay, how do you go about with doing some task like doing it constantly? The way to do it is using the asynchronous operation. That's why the select, async core, and twisteds are. Okay, with asynchronous, you don't do it in a time-wise manner of constantly doing it. You can poll for a particular directory after some time. So it's like this. If instead of constantly monitoring it, you can go for a sleep, come back, look for it. Go for a sleep, come back, look for it. A similar kind of operations are provided by the twisted modules. And so this is again doing the same operation of monitoring a directory by name, logs directory. Okay, what it is doing instead is like it's creating a deferred object. Okay, this is specific to twisted. Twisted works on the see, it's constantly monitoring. When we did something constantly monitoring, we saw that the CPU was 100% utilized. How is your GUI working? So when your GUI something like this, or any pop-up message which comes up, it is like which is like constantly working and constantly monitoring for you to input something there, which is press a button. But it is not occupying your 100% of the CPU time. So what it is doing is it is basically a programming design pattern called a reactor pattern. Okay, if you the reactor pattern. If you Wikipedia for the reactor pattern, it kind of says that it's a design pattern for concurrent programming for handling service requests delivered concurrently, which is like, which is not, it's for request handler. Okay, your GUIs are designed using this reactor pattern, where you don't constantly look for something has clicked or not. Okay, you dispatch something, and then when a particular request has come, you call the function again. Okay, that's what Twisted's working on. It dispatches a function to look for a particular changes in the directory. And when that change has come, only then it triggers. Okay, it's a way of program design pattern which Twisted utilizes, and the same functionality if it is done by Twisted, okay. Okay, that's okay. So it's monitoring. I don't know. I haven't debugged it, but what you got to look at it is the twisted function, which is monitoring a directory, is not occupying the 100% of your CPU. Okay, it's dispatched a reactor pattern and monitoring a file based on the changes to the file. Okay, we'll get back to this program later. It has to give me the whenever a new file has been updated or not. Are in the current directory? Can't stop the reactor that isn't running. I think I have not have the twisted install. That's why it's not running it. Okay, let's go past it. So the point of this was monitoring this directory in an asynchronous manner. Okay, it's again the same function which I used in the previous call, but what it is doing is it is creating a deferred object, and then if a new file has been found, it will call a function on the deferred object, which is similar to how the GUI is working. That it will not hog your CPU, but it will create an object which is like a GUI window, and whenever you create a request on that, it will act. Okay, that was with the process handling. And if you can recollect, we saw how to execute a process, how to handle that process using a subprocess module. You can communicate with the process using a communicate method, pass a command as an input, get an output, get an error, and then we looked at how to monitor a particular directory, which is in a bad way of like doing in a busy way, while loop, and then using twisteds, asynchronous power to do it. And you can also basically sleep and do it, which is not a good way to. Okay, we'll look into the network programming now. So we have network programming, web programming, unit test, programming task, and converting Python 2 to Python 3. Okay, so all of them are interesting. So the network programming, it basically like, so to do any network programming in basics of programming classes, we learn about dealing with sockets in C and C++. Okay, sockets sockets have a particular standard way of dealing, have a standard commands of creating an inet socket and a stream socket. So socket programming always deals with a server and a client. Okay, you create a server, you basically bind that servers to a particular IP address and a port, and you constantly listen for a connection. And once you listen, a client connects to the server, and then you send and receive data. That's what is happening when your browser as a client is connected to a server in the web page. The Apache server is running as a server at the particular port and an IP address, and it's constantly listening for a connect request from a client. And once that connect has happened, it will establish a connection. The browser as a client sends a get request for the page to the server, and the page is in turn sent back to the client. So in order to create a simple server, you have to create a socket, bind the socket to an address and a port, listen for incoming connections, wait for clients, and accept a client and send and receive data. Here's it. In this example, I'm kind of tying it to the IP address directly instead of a local host, because local host can be mapped to a different address. It's okay to use both. 120. So and you basically assign to something higher than 1024 because the rest of the ports are standard. So I'm assigning it to a 5000 port. A socket object is created here, which is a socket inet and a stream socket object. You bind that host and a port to a particular. You bind a particular host and a port to that socket object, and you constantly look for the connections in that socket object. And when a socket connection is received, it kind of accepts the socket connections, and then it can retrieve the client and address. So it can receive the size of values, whichever you specify, the data which you want. From the client, it receives the value, and then it can send the data value to using the client object, using the send method. So the simplest of socket.socket to create a connection, bind it, very intuitive, create a bind, listen for a socket connection, send a data using send method, and receive a data using receive method. At the client, it will be much simpler. You'll have to create a socket object and connect to a particular the servers. So client will have to connect to a particular server's IP address and the port, and then you send a particular value and receive the response back and close it. This is the basics of the socket programming in Python, and socket module is the standard Python library module. Let's look at something interesting of connecting to an IRC port and then monitoring for the changes in the IRC by sending a. So IRC works on the very simple socket connection layer. Okay. So here's the IRC connection. IRC is nothing but a socket object of a inet and the stream socket. It connects to a particular server and a port, which is an irc.freenet.net, which is a standard freenet, and port is 6667, which is the IRC port. After the IRC connection, I do a login using my nickname. So when I do a login, what it's going to ask is it's going to ask for a password, and then it sends a password as my password, and sends my username, host name, server, and the real name, and it sends a nickname, my nickname. Okay, these are all IRC specific commands, which is sending over the socket. Okay, and when I do a join, it has to send a join command to a particular channel, and channel is the Python dev channel. Okay, Python dev doesn't require any password. Okay, and if you see this, for the password, I have used the getPass command. GetPass will prompt for a password so that it's not visible. Otherwise, you will have to place the password in the plain text file, which is bad idea. So as soon as I join, then I am in a busy wait loop again. Okay, but basically it's a busy wait loop. So it's over the socket connection. It's over the socket connection of receiving a particular data. It works only for receiving the data, and as soon as the receive is over, it kind of like goes away. So it receives this. It receives chunks of data using the receive, and then it parses the data using the ping message or the private message, and then depending on the data. So you have established the connection and sent the request. You get the response back. The response is formatted in a particular way. You have to parse the formatted message and then get the response which you want and do whatever you want with it. And in this case, I want to print them so that I have an IRC session. And the good part to note is the try is not caught by an exception. You can do it, but finally is where that which is always executed, I part the IRC channel. Which is good that whenever I close this Python program, I should have logged off from the IRC channel. Otherwise, if I log in from some other client, this program is still running, or I didn't do an explicit part, it will be like a ghost process in that IRC channel. So it kind of sends the commands to the Python IRC, and whoever is going to send some message on the Python IRC, it will be available for it. This is how. So you see that PHOE6, that's my username, which I gave. So it's connected. It's connected, and these are the other users available. So you join it as another user. This is a background implementation of what you see in Pidgin or whatever you use in Mac, which is like the game or Adium, the IRC channel. So behind the IRC channel, it's working like this only. It's creating a socket connection. This is formatted and then shown to you in a good way using the GUI tools available. which is a different task altogether. But the underlying socket connection using the client and the server is this program. Okay. This, in fact, is a good example for socket connection thing. And let's look at this program to see how's it different in Python 3.1 and Python 3.1 and say Python 2.6. You see that Python 2.6, you are passing it as a command, but here, because string is a Unicode string and you want to pass it like a bytes to that object, you are encoding it using the UTF-8. Okay, you are dealing with the connection. You are sending bytes to the server. Okay, you have to encode it in the form of a bytes and send it. Otherwise, it's not going to recognize what you are sending. So in Python 3.1, you are encoding whatever commands you are going to send in the form of a UTF-8 because string is a Unicode string, and when you want to pass it as a bytes, you want to encode it. That's why you have to encode it. The same was, and when you deal with the strings, you might have a yeah, print statement. Print is no longer a statement, it's a function. So you have to, you make use of a function notation instead of a function print statement. That's the difference, okay? You see that where we have to be careful about encoding a particular string to send it as a data. So that was with the network programming and the connecting to the IRC using and logging the messages. Okay. Let's look at some web programming stuff. URL module is the module which is available for. Okay, let me give you some good example of if I ask you to design a web browser using Python, what kind of modules do you think you will use? A web browser with a client. Okay, a client, it should handle the URL, and it should handle the connection, it should handle the formatting, and it should handle the display. Don't think about the object like the GUI and the displays, which are fancy displays which are available. A very primitive web browser should have these functionalities only. It should handle the URL, parse the URL. It should establish a socket connection with the server, send the data to fetch the page, and then once the output is retrieved in the form of an XHTML, you should parse it and then display it, right? So the modules which we saw so far are to establish a socket connection, we saw the socket module. Once you establish a socket connection with the server, you can send a GET request to the page. And once you get the page, which will be in the form of a bytes, you can basically, it will inbuilt convert it back to a string. And the string will be in the form of a HTML, which is an XML. So you might use elementary to parse the XML. And then however you want to display the XML, you can format it and display, which is again according to the standard rules which web browser follow. So you will use elementary module. You can do some string formatting using the string module. But on the first point, if you want to deal with the URLs of fetching a page from the URL, and all those things are taken care of by the URL module. Okay, URL is a higher level function of establishing a HTTP connection with the server, sends a GET request or a POST request or whatever kind of a request which you want, and then retrieves the page back. So whenever you want to deal with the URLs of getting a page, doing a redirection, or doing an authenticate, basically, so for example, you want to write a simple client for Gmail. Not Gmail, but Gmail uses some other things. Also some other website which uses authentication. So you want to create a URL object with the kind of an authentication which is supported by the server. Ask your customer to pass on the username and a password, and then connect it using that URL object to the server, passing on the authentication information, and then you want to get the page. Okay. The whole point is when you're writing clients, you don't have to code the low-level stuff. The abstracts of handling them are available in the form of a module such as URL lib, module such as socket. Okay, URL lib, this module. So let's come back to the first example later. Let's look at this one. Okay. This is a basic authenticated module, okay, which means that I have to pass on the authentication information as my name and the password. So how the URL module works is, it works on basis of, again, a programming paradigm by name, the handlers, okay. It has an open a director and a handler pattern. So it is like this. I'm a director, and I have a number of service handlers. Okay, one service handler will handle HTTP. One service handler will handle HTTPS, a secure method. Another person will handle FTP. Another person will handle, say, SFTP, and another person will handle cookies. What I do is I assign all of them and then make them as, I'm the director. I will have all of them as a handler, and I will give an object for you as a customer. Okay, on that object, you invoke any URL. And based on the URL, I can delegate the functionality for handling the HTTP or HTTPS or SFTP to one of my handler methods and retrieve back your information. So the interface is simple. Import URL lib, URL lib.url open. You see this? The entire the HTML page which we were looking at it right now, okay, is available here. This is how to solve it using Python. The tutorial material was, and this is what the page is. Right? If I click on this, I'll lead to this page. Okay. Look at how simple I did it. I'll do it again. URL lib2 was the standard Python object library. lib2.url open, or it's a file-like object which is returned, and then I read through the file-like object, which will give the Python. So it internally did the socket connection, the HTTP connection, and all those things to it. What I meant to say was HTTPS. Okay, you don't have to worry about it. Okay, it worked. If you have a FTP URL, I don't know. I don't know of any. Wow. You see this? It's an FTP location, and it returned the FTP contents of the thing. Okay. What I mean by that is, again, as I said, URL open or URL lib returns an open a director, and it has a number of handlers with it. And based on the URL you pass, it will invoke the correct handler for it and lets you to fetch the job. For example, in this case, invoke the FTP handler. In the first case, it invoked the HTTP handler. For HTTPS URL, it invoked the HTTPS handler. And now, if you have a HTTPS with the authentication mechanism, for example, for Gmail involved, you will pass the authentication information using the handler object, and then you let him invoke it. And that's what we want to see it in this script. So here, I create an authentication handler with a URL lib.request basic authentication handler. Okay, and for the basic authentication handler, I give the information of for this domain and for this realm, what is the username and password, and I add that authentication handler to that open a director object too. And now, when I request the URL with this particular authentication handler, this authentication will be given priority, and it will authenticate and retrieve the page. Okay, the same is the case with the digest authentication handler. So this is a live journal page of retrieving the RSS feeds, and which is authenticated using the digest algorithm. Okay, so if you know of the authentication schemes, there are two basic authentication schemes available in HTTP, which is basic and the digest. Basic is like I think it's the basic is kind of simpler, where it hashes the function and looks for the particular hash value over there in the next end. Digest is somewhat complicated, where it creates an MD5 sum and then combines with the no one's value, and it does quite a lot of things where it's more secure. So everyone uses digest authentication only. Basic authentication is like a toy. So in order for the digest authentication work, you again create a handler and pass on the username and a password, and then you install that handler for the opener director, and then let the URL open to do its job using the username and handler. Okay, let's look at this. Let's execute the digest authentication handler example. So, okay. Yeah. So yes, it has retrieved it from the contents of the basically RSS feeds only. Okay. What I'm showing you is what is happening in the background layer, where the Python is used in the clients, and this is how it is usually written. And then you write something on top of it to wrap it, or you give it to someone else who does the front-end task of it. Okay. This was an example of passing a digest authentication to the URL module, and then authenticating using the username and password and retrieving the content. Okay. Subclassing. So you know that one particular link redirects to another link. And there are different kinds of redirections available. Okay, URL module handles them for you automatically. Okay, suppose if you want to control the kind of redirection happening, what you want to do is understand that where it is handled in the module, and then you subclass the module to handle them. In this example, URL, as I said, that the HTTP handler, okay, is the one which is handling the HTTP request, and whenever it finds that there is a redirect happening, it invokes this function by name HTTP error 302. You will come to know when you browse the source code of it, which is available. Now what you are doing is you are writing a smart redirect handler of capturing the redirected output and the status code, okay, which URL-lib2 will not show you. So this is your custom built function where you have created a class of smart redirect handler, which is subclassing the URL-libs2 basic redirect handler, HTTP redirect handler. And in that, what I'm doing is basically capturing the code of the redirection, 302 redirection, and then returning the result object of the redirection. Okay. How I'm going to do it, again, I'm calling the URL-lib2's HTTP redirect handlers the same object. This object and this method is same. I'm extending the functionality of the default available handler by, I'm just extending the functionality of the default available handler. And instead of using the standard HTTP redirect handler, I am asking him to use my smart redirect handler. Okay. When I'm asking him to use my smart redirect handler and I'm opening a request object using this one. Okay. By the way, URL-lib2, when I showed that URL-lib2.request, So in the previous example, I passed on the URL directly to the URL open. Here I am creating a request object and then I am passing the request object to URL open. Both are same. URL open is a convenience function which is internally creating a request object and then passing on to it. In this I am doing it explicitly. So here in this particular function, I am creating a request object for this particular URL which I want to open. And then I'm building a new opener with a smart redirect handler, which is, as I am a director, I don't want to use the HTTP redirect handler, but I want to use the smart redirect handler, which is a little bit smarter than the basic handler. And then I install that particular smart redirect handler here, build opener. Okay, the build opener function will create an opener using the smart redirect handler, and when I request it, I will have the object.status, which is available from this only. So I will have the status object provided by the new handler. This example shows how will you subclass a standard library module with an added functionality which you want to use. Huh? Oh, I don't have in the form of a snippet. I think I just capture the code. Okay, so this function was not invoked because there was no redirection happening. Okay, this function will get invoked only if there is a redirect happening in the URL. If I have a particular URL which is redirected by the proxy, and then it is a 302 redirection, only then this function will get invoked. And on that redirection, we can get the status code. Okay, that's an example of a smart redirect handler. Okay, any questions so far? Are we good? Or you want me to cover something? You get an idea of how things work in the background, right? That's what I want to make sure. And you can use Python to do things in the background of writing a client, doing automation stuff, and do a lot of things, socket programming, browsers. This how to solve it using Python is, if you want to write a browser-like software, how will you do it using Python? Using these kinds of standard library modules. Yeah? So we'll go ahead. How much more time do we have? Yeah. Huh? One more hour? Oh. Oh my God, I'm sorry. So yeah, let's quickly cover through the unit test stuff, and the programming tasks. And I want to give this 2 to 3 tools because right now you're using Python 2. You will want to use the Python 3 subsequently because it's the future of the language. So basically, to migrate the Python 2 source code to Python 3, you will have to use it. Let's look at the unit test. Unit test is nothing. It's again a module by name unit test. When you're writing a unit test, you will subclass the unit test module's test case and create a function. And all the methods you have, like test underscore test, it will run that unit test functions. Unit test is nothing but your method is supposed to do some things. A random.sort. A sort function should return a sorted list. So you will create a sorted list upfront. You create a list, you run a sort method, and then you compare if the sorted list is equal to the sort you upfront created. So this is what a unit test module is supposed to run in such a way that it will automatically discover it will automatically run all the functions which start with the test underscore, some method name. And it will give a report of what are test functions did it run, and what is the result of the test functions. This is the way to run the unit test module too. Python -m unit test, module name 2, and if you want to run a particular test class or a test method and all those things. And in recent versions of Python, you have the test discovery available, which means that you can do a Python -m unit test and discover. It will find all the test-related modules and do a quick test of all the run a test of all the test libraries which are available. Okay. So look at this name tuple, okay, which is like if you want to create a class, it's a convenience function also available where you want to create a class, okay, and for each element of a tuple you want to assign a name to it. You can use the name tuple available to it. And this is something which we already saw in the break, that sort was executing much faster than the other things because it is using timsort and it works good on an already sorted list. The name tuple so collections module provides a method, provides a convenience function, convenience module by name tuple, method by name tuple, which takes a class name. It takes the name of basically the two names you want for the values, and the verbose is equal to true will print out the class which is generating. Okay, this should have returned a class. And now when I create a point class object with two arguments 10, 20, I can access them using the names which I have given here. So if I give them as James J, Y, I can access them as J, Y2. And here is the convenience function which is automatically generating a class for you so that you don't have to bother writing this good class, and you can access them using the J, Y variable. Okay, let's look at the last one, which is example for 2 to 3 conversion. So this is a Python 2.3 file, okay, which has all the methods which are available for you. Basically doc strings and list of Unicode strings and not equal to examples, because not equal to is not available in Python 3. Okay, what you do is 2 to 3 is the tool which is available from the Python's SVN repository when you're downloading the Python source code, or Google for 2 to 3 tool, and then run it against this module. Okay, what it will do is it will print out, it will refactor it, and then it will print out the module. Here it is. It is created a diff of what needs to be changed and this thing. Okay, a better convenience function available is example for 2 to 3. I'm copying this to a particular file. I'm running 2 to 3 with a -w argument. Okay, and I'm executing it on the example3 file. Okay, it must refactor it and then write to a file. So if you find example_3, this is your Python 3 code. Okay, and if you see the Unicode examples, you can see them that they are no more Unicode, but they are the Python's tree functions. It was written by Guido, Colin Winters, and then Benjamin. It's a good tool in itself. It parses the Python code. It understands what are the changes from the Python 2 to Python 3, and then writes out the Python 3 source code for you. But still, you cannot rely on this completely, because it is you will have to take care of what encoding of strings and the bytes which you'll have to send. Like we saw in the examples that sometimes you have to send across the bytes, so you have to encode the string and send it. Sometimes you have to deal with the bytes, so you will have to make the bytes string, which this tool will not. But this will take care of all the syntax for that. This source code is also available in that, and you try with the Python 2 to 3, you will get familiar with it. That's it I had. Thank you. Thanks for your patience and thanks for listening. I hope it was useful.